Flexible metal conduit, commonly referred to as FMC and sometimes colloquially as Greenfield, is addressed in the National Electrical Code, specifically in Article 350.10 for FMC itself and 358.10 regarding its permitted uses. In the 2020 NEC, Section 358.10 addresses the permitted uses of FMC. Subsection 4 states that FMC is permitted as a fixture supply where a maximum of 6 feet of FMC is used to extend the fixture supply from a box. This means that when FMC is used as a fixture whip, the maximum allowable length is 6 feet. Section 358.50 covers grounding requirements for FMC. Subsection addresses bonding where required. Paragraph 2 stipulates that FMC shall be bonded to the grounding electrode system at the service equipment. Paragraph 3 indicates that FMC shall be bonded to the grounding electrode system by any of the methods specified in 250.92. Subsection B addresses the continuity of the grounding path. Paragraph 1 states that it shall be permissible to use a bonding jumper in FMC that is not longer than 6 feet. This implies that for FMC runs exceeding 6 feet, grounding connectors are required to ensure a continuous and effective grounding path. Section 358.60 addresses securing and supporting FMC. Subsection A covers general requirements. Paragraph 1 states that FMC shall be securely fastened in place. Where necessary, straps, brackets, or other approved means shall be used to prevent sagging. While FMC must be securely fastened and supported, there is no specific length limitation regarding this requirement. To summarize, firstly, when FMC is used as a fixture whip, its length cannot exceed 6 feet according to NEC Section 358.10. Secondly, for FMC runs longer than 6 feet, grounding connectors are mandatory to maintain grounding continuity, as inferred from Section 358.50. Thirdly, all FMC installations, regardless of length, must be securely fastened and supported to prevent sagging, as specified in Section 358.60. The 6-foot limitation is specifically applicable to fixture whips, which are short runs of flexible conduit used to connect a lighting fixture or other electrical device to a junction box. For longer runs of FMC, the code emphasizes proper grounding and support. Grounding is crucial for electrical safety. It provides a low impedance path for fault current to return to the source, allowing overcurrent protective devices like circuit breakers to trip and to energize the circuit in the event of a ground fault. Without proper grounding, a ground fault can create a shock hazard. The requirements in 250.92, which are referenced in 358.50, provide detailed methods for bonding electrical equipment to the grounding electrode system. These methods include using bonding jumpers, listed grounding connectors, and other approved means. The purpose of bonding is to ensure that all metal parts of the electrical system are at the same electrical potential, minimizing the risk of electric shock. The support requirements in 358.60 are essential for maintaining the integrity of the FMC installation. Unsupported FMC can sag, which can put stress on the conductors inside and potentially damage the conduit itself. Straps, brackets, and other approved support should be used to keep the FMC run straight and prevent them from sagging. The spacing between supports will depend on the size and type of FMC, as well as the specific installation conditions. A national electrical code is updated every 3 years, so it is important to always refer to the latest edition to ensure compliance with the most current requirements. The specific sections and paragraph numbers mentioned here are based on the 2020 NEC, but they may be different in other editions. When working with electrical systems, it is always best to consult with a qualified electrician to ensure that the work is done safely and in accordance with all applicable codes and regulations. The NEC provides minimum standards for electrical installations, but local jurisdictions may have additional requirements. It is the responsibility of the installer to be aware of and comply with all applicable codes and regulations. Understanding the purpose and intent of the code requirements is just as important as knowing the specific rules themselves. The NEC is not just a set of arbitrary rules, it is a comprehensive set of safety standards designed to protect people and property from electrical hazards. By following the NEC and using good workmanship practices, you can help ensure that electrical installations are safe and reliable. In addition to the specific requirements for FMC, the NEC also contains general requirements for wiring methods, grounding, and overcurrent protection. These general requirements apply to all electrical installations, regardless of the type of wiring method used. It is important to be familiar with these general requirements as well as the specific requirements for FMC. For example, the NEC requires that all conductors be protected from overcurrent by circuit breakers or fuses. The size of the overcurrent protection device must be matched to the ampacity of the conductors. The NEC also contains requirements for the installation of boxes and fittings. Boxes and fittings must be listed for the intended use and must be properly installed to provide mechanical support and protection for the conductors. The NEC also addresses the issue of voltage drop. Voltage drop occurs when the voltage at the load is less than the voltage at the source. Excessive voltage drop can cause equipment to malfunction and can also reduce the efficiency of the electrical system. The NEC provides guidelines for calculating voltage drop and recommends that voltage drop be limited to a certain percentage of the source voltage. The NEC also contains requirements for the identification of conductors. Conductors must be identified by color coding or other approved means. The purpose of conductor identification is to make it easier to identify the different conductors in a circuit and to prevent accidental connections. The NEC also addresses the issue of working space around electrical equipment. Sufficient working space must be provided around electrical equipment to allow for safe access and maintenance. The amount of working space required depends on the voltage of the equipment and the location of the equipment. The NEC also contains requirements for the installation of ground fault circuit interrupters, which are commonly known as GFCIs. GFCIs are designed to protect people from electric shock. They work by detecting small amounts of current leakage to ground and interrupting the circuit. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas. The NEC also addresses the issue of surge protection. Surge protection devices, also known as SPD, are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning, switching of electrical loads, and other events. SPD are installed at the service entrance or at individual pieces of equipment. The NEC also contains requirements for the installation of smoke detectors and carbon monoxide detectors. Smoke detectors are designed to detect smoke and alert people to a fire. Carbon monoxide detectors are designed to detect carbon monoxide gas, which is a colorless, odorless, and poisonous gas. Smoke detectors and carbon monoxide detectors are required in dwelling units and other occupancies. The NEC also addresses the issue of energy efficiency. The NEC contains requirements for the installation of energy-efficient lighting, motors, and other equipment. The purpose of these requirements is to reduce energy consumption and save money. The NEC is a complex and comprehensive document, and it is important to stay up to date on the latest requirements. The NEC is updated every 3 years, and each new edition contains changes and revisions. To stay current with the NEC, you can attend training courses, read industry publications, and consult with qualified electrical professionals. In addition to the NEC, there are also other codes and standards that may apply to electrical installations. These include local building codes, state electrical codes, and industry standards such as those published by the National Fire Protection Association, commonly referred to as NFPA, and the Institute of Electrical and Electronics Engineers, commonly referred to as IEE. It is important to be familiar with all applicable codes and standards before beginning any electrical work. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazards. Always to energize circuits before working on them, use appropriate personal protective equipment, and follow safe work practices. If you are not qualified to perform electrical work, hire a licensed electrician to do the job. A licensed electrician has the training and experience necessary to perform electrical work safely and in accordance with all applicable codes and regulations. The information provided here is for general educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrical professional before making any decisions about electrical installations. Remember that safety is always the top priority when working with electricity. Take your time, follow the rules, and never take shortcuts. By following these guidelines, you can help ensure that electrical installations are safe and reliable. The intent of the 6-foot rule for fixture widths is to allow some flexibility in positioning the fixture while maintaining a secure and grounded connection. Longer runs of flexible conduit are more susceptible to damage and can be more difficult to ground effectively, which is why the code requires grounding connectors for runs exceeding 6 feet. Grounding connectors provide a low impedance path for fault current to flow back to the source, which helps to ensure that overcurrent protective devices will trip quickly in the event of a ground fault. The type of grounding connector used will depend on the size and type of conduit, as well as the specific installation conditions. Some common types of grounding connectors include grounding bushings, grounding wedges, and grounding lock nuts. When installing grounding connectors, it is important to follow the manufacturer's instructions carefully to ensure a proper connection. The support requirements for FMC are intended to prevent the conduit from sagging or becoming damaged. Sagging conduit can put stress on the conductors inside and can also make it difficult to pull wires through the conduit. The spacing between supports will depend on the size and type of conduit, as well as the specific installation conditions. As a general rule, support should be installed at least every 4.5 feet for trade sizes 0.5 inch through 1 inch, every 5 feet for trade sizes 1.25 inch through 2 inch, and every 6 feet for trade sizes 2.5 inch and larger. In addition to the spacing requirements, the supports themselves must be strong enough to support the weight of the conduit and the conductors inside. Support should be securely fastened to the building structure using screws, bolts, or other approved fasteners. When installing FMC, it is important to avoid sharp bends or kinks in the conduit. Sharp bends can damage the conduit and can also make it difficult to pull wires through the conduit. The minimum bending radius for FMC is typically 4 times the trade size of the conduit. For example, the minimum bending radius for 0.5 inch FMC is 2 inches. When pulling wires through FMC, it is important to use a wire lubricant to reduce friction. Wire lubricant will make it easier to pull the wires and will also help to prevent damage to the insulation. It is also important to avoid overfilling the conduit with wires. The NEC specifies the maximum number of wires that can be installed in a given size of conduit. Overfilling the conduit can make it difficult to pull the wires and can also cause the wires to overheat. The NEC also contains requirements for the protection of conductors from physical damage. Conductors must be protected from physical damage by conduit tubing or other approved means. In areas where conductors are exposed to physical damage, such as in industrial environments, it is important to use a rigid wiring method such as rigid metal conduit or intermediate metal conduit. The NEC also addresses the issue of corrosion. In corrosive environments, it is important to use corrosion-resistant materials for conduit boxes and fittings. The NEC also contains requirements for the installation of electrical equipment in hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. Electrical equipment installed in hazardous locations must be specifically designed and approved for use in those locations. The NEC also addresses the issue of electrical safety in healthcare facilities. Healthcare facilities have unique electrical safety requirements due to the presence of sensitive medical equipment and the vulnerability of patients. The NEC contains specific requirements for the grounding and wiring of electrical systems in healthcare facilities. The NEC is a living document that is constantly being updated to reflect changes in technology and industry practices. It is important to stay up to date on the latest requirements to ensure that electrical installations are safe and compliant.